In this video, we're going to take a look at another example of integration by parts. In this case, what we want to do is evaluate this indefinite integral, and that is the integral of tan inverse. So when you first see this problem, you might say, well, wait a second, this is not a product of two functions, it's just the tan inverse function. So how would I use integration by parts on this? And it pretty much runs exactly the same way as you would in any other integration by parts, right? If you go by the LIAT guidelines, right? The second, the I in LIAT, right, is inverse trigonometric. And so that would be your choice for you. And there are no logarithmic functions in here at all. So if you follow those guidelines for this problem, then you would choose u to be tan inverse x. And in fact, that's exactly what we would want to do. And now the question is, okay, that kind of makes sense, but what about dv? There's nothing to be dv. And if that's the case, then what you do is just put dv equals dx. And again, it does satisfy that criteria that we talked about, in the sense that if I take and multiply u and dv together, I should get exactly the original integral. Everything should be accounted for. And you can see that same thing. U is tan inverse x. If I multiply that by dv, which is dx, I get tan inverse x dx. Okay. All right. And then from there, we would calculate du and v. Du is 1 over 1 plus x squared dx, and integrating dv, right? If I integrate 1 with respect to v, I get v. If I integrate 1 with respect to x, I get x. Okay. And then from there, we would follow the formula for integration by parts. So we wind up with uv, so that would be x tan inverse x, minus the integral of v, which is x, times du, which is 1 over 1 plus x squared dx. Okay, and now we just need to complete this integral to complete the problem. Okay, and so looking at this integral, it winds up to be a rational function, right? And we have on the bottom 1 plus x squared, and on the top x, right? And so what those tend to be are just plain substitutions, right? Where u is the bottom part here. So if I let u equal 1 plus x squared, right, then my du will be 2x dx, which almost works out perfectly, right? I have the x and I have the dx, but I don't have the 2 in there. So what I would do is adjust by multiplying both sides by half, right? And so then I have exactly x and dx. That's exactly what I have to account for in this integral. So I would go ahead and make the substitution. The 1 over 1 plus x squared becomes 1 over u, and the x dx, right, become 1/2 du. And then use the constant multiple rule to pull the 1/2 out. And I have the integral of 1 over u du, and that is just the natural log of the absolute value of u. And then back substitute, right? U is 1 plus x squared. And I've removed the absolute value bars because for any real number x, right, 1 plus x squared will wind up to be positive, and the absolute value of any positive expression, right, would just be itself. Okay, and that's it for this example.